Now here we're going to look at matrix multiplication, and we're going to first look at what's called scalar multiplication, and that's where we just have a single number multiplied by a matrix. And this multiplication is pretty straightforward. It's kind of what you would probably assume. We're basically just going to distribute the 4 here to every entry in the matrix. So in this case, we would simply just end up with 4 times 2 is 8, 4 times -1 is -4, 4 times 0 is 0, 4 times 7 is 28. And there's your answer. So basically you're just distributing the 4 to every entry. And if we look at another example here, we have a -1/2 multiplied by the 2 by 2 matrix 9, -6, 2, 5. And once again here, -1/2 times 9 would be a -9/2. -1/2 times a -6 would be a +3. -1/2 times 2 would be a -1. And a -1/2 of 5 is a -5/2. And then if we look at the next example, we're kind of putting this together with our addition and subtraction. And if you notice here, we have parentheses. And again, we're going to follow the same rules with parentheses. We're going to do what's in the parentheses first. So here we would have a -3 multiplied by what's in the parentheses added together. So we're going to add the two matrices inside together. So 0 and -6. Here we would end up with -6. And then we have -3 and 3, which is 0. 7 and 8 is 15. 2 and 1 is 3. And now when we go to the next one, we have here a -2 being multiplied by the matrix. Now there's two ways you can do this. One way is we can distribute only the 2, a +2, and we would leave the sign here as negative, and we would get 8, -8, 14, and -18. Now, what I prefer to do here in this example is to not distribute the 2 only, but to actually go ahead and distribute the negative with it. And if we do that, then this is going to become addition, and then we would end up with -2 and 4, which is a -8. -2, -4 is a +8. -2 and 7 is a -14. -2 and -9 is a +18. And the reason I like to do this is because it kind of eliminates your negative sign here out front, so it makes it easier when we're adding your matrices instead of subtracting. All right, now we need to go to the front and we need to multiply the matrix by 3, or -3. So here we're going to be multiplying with the -3. So if we multiply everything by the -3 here, we're going to get a +18. -3 and 0 is 0. -3 and 15 is a -45. And -3 times 3 would be a -9. So then we're going to take and add this to the other matrix. And again, you're just going to add your corresponding entries. So again, you're going to add 18 and -8. So that would be 10. And then 0 and 8 is 8. -45 plus a -14 would be a -59. And a -9 plus 18 is a +9. So here is our answer. So we're still going to keep the same basic rules of order of operations when we have our parentheses. All right, now we want to move on to what is actually called matrix multiplication, and this is where we're going to multiply two matrices together. And this is sometimes referred to as row by column multiplication, because we're going to take and multiply the row by the column. Now pay close attention, this is going to be a little bit different here. If you notice here, we have a 3 by 2 matrix, and we're multiplying this by a 2 by 2. Now when we multiply here, if we start with what's called a m by n, you have to multiply this by an n by, we'll say, p. In other words, up here, the number of columns here is 2, which is our n, has to match up with the number of rows that you have in what you're multiplying. Otherwise, you cannot multiply these together. And your answer, when you multiply here, these two together, should be an m by p. All right, now this will make more sense once we multiply this out, but I want to look at now multiplying these two matrices together. So we're going to take this first row right here, which is negative 1, 3, and we're going to multiply it by each column over here. So I'm going to write this as negative 1 and 3. Okay, so we're going to take and multiply here the negative 1 times negative 3. Okay, and then you're going to take and multiply 3 times negative 4. So that's going to be plus 3 times negative 4. And this is your first entry. And then you're going to take the negative 1 and 3 and you're going to multiply it by the next column, which is the 2 and 1 over here. So it would be negative 1 times 2. And then you would take 3 times 1, so it's plus 3 times 1. And that's your second entry. And then we're going to move down to the next row. We have 4, negative 2. So here we would multiply 4 and negative 2. So we're going to take 4 times negative 3. And then you're going to take negative 2 times negative 4. So negative 2 times negative 4. And now for the next entry, you're going to still take the 4 times 2 plus negative 2 times 1. And then we're going to move to the next row, 5, 0, and we'll do the same thing. 5 times negative 3 plus the 0 times negative 4. And then you're going to multiply again by the 2 and the 1, so 5 times 2 plus 0 times negative 1. Or, I'm sorry, 0 times positive 1. So now all we have to do is simplify each one of these. Now at first, I know this looks a little confusing and quite different, but once you look at this a little bit, it'll make a lot more sense. So if we look at the first part here in blue, we have negative 1 times negative 3, so that's 3 plus a negative 12, so that's going to be a negative 9. Then over here we get negative 1 and 2 is a negative 2 plus 3, which would be a positive 1. 4 negative 3 is negative 12 plus 8, so that's going to be a negative 4. Whoops, keep the same color here. So this would be negative 4. And then 8 and negative 2 would be 6. 5 and negative 3, so that's a negative 15, and that goes to 0, so this would be negative 15. 5 times 2 is 10, plus 0 is 10. And this is where, if you notice, where I said we would end with a m by p, so in this case, our m would be 3 by 2. So notice here we have a m by p matrix as our answer. This is the order. And for us, that means we're going to have a 3 by 2 matrix. So that's where your row has to be equal to your number of columns in order to multiply. So that's your answer. Now, what if we took and switched the order? So for example, if I call this here if this was matrix A and this over here was matrix B, then here's the answer, A times B. But what if we switch the order? Down here, what happens if I take and try to multiply B times A? Well, first of all, does the number of rows match with the number of columns? And if you look at this closely, you're going to say, well, the answer is no. And that means here, if we were to take the negative 3 and 2, and we try to multiply that here, we would have a negative 3, we would have our 2, but then notice we don't have a number to multiply here. So in other words here, they do not match up, so therefore this multiplication is not possible, or it is undefined. So again, the number of rows has to equal the number of columns here. So this tells us here that the order that we multiply is important. Whereas we know that if we normally just take two numbers such as 2 and 3, 2 times 3 is 6, and we can switch the order, 3 times 2 is 6. But when it comes to matrix multiplication, the order in which we multiply is important, and it does make a difference. All right, so let's take a minute here now, and let's see how we can take this example that we started with, multiplying together, and we can actually put this in the calculator. We're going to go to matrix. Now again, you would hit your matrix button, and that may require you to hit second function and matrix. We're going to scroll over to edit, and I want to edit number 1, so we'll select number 1. And our first matrix that we have here is a 3 by 2, so we need to type in 3, enter, 2, enter, and then we're going to type in the entries. We had a negative 1, 3, 4, negative 2, 5, and 0. And then I'm going to quit, second mode, and then I'm going to go back into the matrix. I'm going to scroll over to edit, and now we want to type in matrix B, which was the negative 3, 2, negative 4, 1. So this is going to be a 2 by 2 matrix. Now, when I go to edit, I want to make sure I select number 2 so we don't type over what we just put for matrix A. So I'm going to select number 2, and we said this had to be a 2 by 2 matrix, which would be negative 3, 2, negative 4, and 1. And once again, I'm going to quit to get out of the edit mode. And then I'm going to go back into the matrix. I'm going to select matrix A, which is 1, and we're going to multiply that by matrix B. So go back into the matrix and select 2, which is matrix B, and we hit equals, and we get negative 9, 1, negative 4, 6, negative 15, 10, which is exactly what we had here when we did this by hand. Now, what happens, let me clear the screen, what happens if I go into second matrix, select B, times, go in, select A, and hit enter. Notice here it says dimension mismatch. So in other words here, the dimensions do not match up. And for example, if I select go to, it's going to kind of click here and indicate that the dimensions of matrix A and B don't match up so that we can multiply, and that's because the rows and columns do not match. So scalar multiplication, you just basically distribute the scalar number out front. With matrix multiplication, you need to make sure that the number of rows equals the number of columns here, because we're going to take this row by column multiplication.